Alright, to find these linear models, let's see what they're first asking us to find a linear model such that X represents years after 2000 and E represents enrollment. So first of all, E will be like our Y value. And second, our X needs to be represented in years after 2000. So let's look at the part-time male students. This information right here can be written as two separate ordered pairs. So in 2014, there were 5,781 students, and then in 2006 there were 4,853. The important thing is that we need our X values here to be in terms of years after 2000, so we're not going to use 2014 and 2006. Instead, what we're going to use are these ordered pairs with our X values represented as, again, years after 2000. So this will be 14 instead of 2014, comma 5,781. Instead of 2006, years after 2000 means 6, and 4,853. So this is the first significant step, is to use these two ordered pairs for the information. So now we're going to create our linear model. In order to create our linear model, we need to find the slope between these 2 points, so the changes in the y values, which would be 5,781 minus 4,853 over the change in the x values, that's just 14 minus 6. Important to this point is that if we take this first number and then subtract this second number from it in this order, in order to get the right slope, positive or negative, we need to do the same order with the x values. Take this first one and subtract the second one from it, as I've done down here. And after throwing those in the calculator, what we get is 928 over an 8-year span. And again, what this represents is between these 2 years there's a difference of 928 students. This is saying that's in an 8-year span from 2006 to 2014. That gives us an average difference of 116 students per year. This right here is our M value. So our linear model now looks like E equals 116x plus B. We found our slope, or this M value. To find this B value, we're going to plug in one of these points. Let's plug in this first point right here. So we're going to plug in the information for x and y from 14 for the x and 5,781 for the y. That's looking a little crazy, but let's plug in those numbers again for x and e, and we're going to use those pieces of information to solve for b. So our e value here again is 5,781, and then 116 times x, which was 14 in that case, plus b. Do some quick multiplying there. 116 times 14 is 1624 plus b. Subtracting the 1,624 from the 8,781, we get 4,157 equals our b value. So just in recap, we started with our general form of the equation, E equals mx plus b. We found the slope between those 2 points, which in this case, the slope represents the number of students per year on average that are joining the male part-time enrollment. We plugged that in to our form, and then we took either one of the points. We decided to plug in the information from 2014 in for x and e. X again is the years after 2000, and E is the enrollment. We use that to solve for B, and then what we end up with, again, B is 4,157. Our final, we get a linear model that is E equals 116, so the students grow at 116 more students per year, plus our y-intercept value, which in this case is the enrollment or projected enrollment in year 2000, which is 4,157. And then if we wanted to go about finding the model for the part-time female students, we would go about it in exactly the same process. First, adjust that information to be in years after 2000. Find the slope, again making sure we subtract in the same order. We should get positive values for these. These are growing. Once we find that slope, plugging one of the points back in, it never matters which one we plug in, to find our b value. Once we found our b value, we have our final linear model.